Hi everyone, and welcome back to the topic which we are going to discussing into the MC2, that is about the diuretics. Okay, so in the anti-anginals we are discussing about the diuretics, right? So from last few classes we have been learned about the what are diuretics, and followed by the what is the main classification of diuretics. Okay, we have been seeing as per the given syllabus point of view, including the structures. Okay, now in this class we are going to specially focus to learn about the one by one class of these diuretics has been given in the syllabus, and followed by their mode of action. Okay, how they are showing exact their diuretic activity we are going to be learning in this, right? So in this diuretics classification, the first one has been given about the diuretics to study about the carbonic anhydrase inhibitors. Okay, right? Carbonic anhydrase inhibitors. Sometimes they are also called as CA inhibitors. Okay, that is called CA. That is called carbonic anhydrase. Okay, CA inhibitors. Okay. So as per the syllabus, there are three important molecules as given, or three important drugs are being given as a diuretics. Okay, one is about the acetazolamide, another is about the methazolamide, another is about the dichlorofenaramide. So both acetazolamide and methazolamide are some of the important thiazole sulfonamide derivatives. Okay, whereas the dichlorofenaramide is about the same sulfonamide derivative of the aromatic moiety. Okay, now in this class, how this drugs or these diuretics are showing their diuretic activity by the inhibition of this carbonic anhydrase inhibitors. Okay, and followed by the specific uses of each and every drug molecule, that is diuretics, has been given in this part, right? Yeah. So next is about the mode of action of the carbonic anhydrase inhibitors. Mode of action of carbonic anhydrase inhibitors. Okay, here how these carbonic anhydrase inhibitors showing their mode of action, mechanism of action or mode of action, and followed by the how they are showing the diuretic activity, right? So if you do remember, right, in the last class we have discussed about this is the Roman tubule, right? So right, Roman tubule, where we have seen about the different parts of this tubule, right? Okay, so in this tubule, okay, here is about the this is called the PCT, right? This area is called as a PCT, that is proximal convoluted tubule, right? In the Bowman tubule there are different parts like proximated convoluted tubule and loop of Henle. Okay, likewise we have seen the different parts of this Bowman tubule. In this Bowman tubule we have first one we have learned about the proximated convoluted tubule. Okay, this is where exactly the carbonic anhydrase enzyme will be present. There we have been discussed, and especially among the diuretics classification, like carbonic anhydrase inhibitors and followed by the osmotic inhibitors are showing their mechanism of action at the PCT, like proximal convoluted tubule part of the Roman tubule. Okay, right. So this is where the enzyme will be present here. Okay, so this is where the calcium carbonic anhydrase inhibitors showing their mechanism of action. Okay, so here if we specially focused on this part of this PCT, like proximated convoluted tubule. Okay, where inside there is a urine and followed by the blood. Okay, in the basolateral. Okay, so what will happen? Okay, so the carbonic anhydrase is one of the important enzyme. What will happen here in this this PCT, proximal convoluted tubule cell? What will happen? The both water and followed by the carbon dioxide, right? Water and carbon dioxide will go moving inside outside from this PCT and urine production. Okay, where the water and carbon dioxide are converted into the carbonic acid, H2CO3. Okay, again this H2CO3 is again converted to the bicarbonate ion and followed by the H plus ion, right? So here this H plus ion and bicarbonate ion will be produced here. Okay, so this carbonic anhydrase inhibitor play important important role here in this area, this PCT, where the exchange of H plus ions will takes place, okay, in between the PCT and urine production. Okay, basically the carbonic anhydrase inhibitor, this is where there, so it will convert the both, water into the water and carbon dioxide into the carbonic acid, and followed by the carbonic acid is again converted into the this H plus and bicarbonate, and the H plus and bicarbonate is in equilibrium or exchange with the sodium ions. Okay, sodium ions. Okay, so the natural one that is to be occurred, okay, the carbonic anhydrase, it will play important role for the formation of carbonic acid, and followed by the bicarbonate and H plus ions. Exchange of H plus ions will take place from the PC to the urine. Okay, but now what will happen? There is a natural process that will occur. Okay, but when it comes to the the inhibitors, like if this carbonic anhydrase, okay, is enzyme, okay, there are certain kind of molecules that have been developed, or those molecules, how they will do, how they act, they will inhibit the carbonic anhydrase enzyme. Okay, the moment they will inhibit the carbonic anhydrase enzyme, CA enzyme, what will happen? So instead of inhibit that enzyme, what happens? So what is the natural process will occur, like H plus and Na plus ions. Okay, the exchange of H plus and Na plus ion will take place. That means the extent of sodium ions will move towards the urine. Okay, so likewise, so the sodium ions concentration will increases, okay, in the urine concentration, and the sodium ion will be like leaved, okay, will be eliminated through the urine in the high excess concentration. Okay, so likewise the sodium extent of sodium ions will be removed by the inhibition of this calcium carbonic anhydrase inhibitors. Okay, exactly. Similarly, so because the sodium ion is eliminating, the extent of potassium ion concentration will be increased. Okay, here in this case. Okay, so if the extent of potassium ions concentration increase, then what will happen? There is a condition called a disorder condition called hyperkalemia. Okay, it's a metabolic disorder. That means the extent of potassium ion concentration will increase. Okay, inside the body. Okay, that is called as hyperkalemia because of the excessive loss of the sodium ion because of this carbonic anhydrase. Okay, yeah. So the exact mechanism is like the enzymes, like basically the enzyme carbonic anhydrase helps to make the H plus ions available for exchange with the sodium and water in the PCT, okay, proximal convoluted tubule. Okay, so what it will do, it will make more availability of the H plus ions we have seen here, right? This is the more availability of this H plus ions here, and this H plus ion more availability will leads to the exchange of that H plus ion with the sodium ions, and followed by the water molecule in the proximal convoluted tubule, that is called PCT. So what they used to do, carbonic anhydrase inhibitors, what they used to do, they will block the action of carbonic anhydrase, okay, like acetazolamide, and followed by the methazolamide. Okay, and followed by the dichlorofenamide. What they will do, they will inhibit this enzyme, carbonic anhydrase enzyme, and what will happen, thus preventing the exchange of H plus ions with the sodium and water. Okay, so what they will do, they will prevent the exchange of H plus ions and with the sodium and water. Okay, so that reduces the H plus ion concentration in the renal tubule. Okay, so the H plus ion concentration in the renal tubule will be decreased. Okay, then what will happen? Then what is the result that because of this consequence, right? So result is simply the increased excretion of bicarbonate, like sodium bicarbonate, and followed by the sodium and water and potassium sometimes, okay, very less. Okay, basically they will excrete the most of the sodium and potassium in the form of sodium ions, potassium ions, and followed by the bicarbonate form. Okay, they will be excreted inside the body. The moment when they will decrease their concentration of sodium and potassium, okay, leads to the any kind of condition through the urine. What will happen? Any kind of condition like heart like feeling, like the heart pain like feeling, which is occur like angina, that will also be reduced because of the less concentration of the sodium and potassium ions inside the body, or in the inside body around the heart or vascular smooth muscle. Okay, another is about the reabsorption of water is decreased, and followed by the urine volume is increased. Okay, So reabsorption of water is decreased, then automatically the urine volume will also be increased. That leads to the urosis. That is called the urosis. Okay, so yeah. Okay, so yeah, that's how they are this acetazolamide and methazolamide and dichlorphenoramide showing their diuretic activity. Now we'll go by one. Okay, the first molecule has been given as a carbonic anhydrase inhibitor. This is about the acetazolamide. Okay, so we have seen this acetazolamide is a like a thiazole ring, like having the 5 membered ring with the sulfur and 2 nitrogens adjacent to each other. There is sulfonamide moiety, there is a N-acetate moiety. Okay, there is a N-acetate moiety. Okay, so these three simple parts, heterocyclic ring, sulfonamide, and followed by the substituted amine which is attached with the this acetazolamide. Okay, so I mean technically acetazolamide is a common and highly commercial name, but when it comes to the IUPAC name, it will comes under the N5 aminosulfonyl 1,3,4 thiadiazole 2-yl acetamide is the IUPAC name for the acetazolamide, right? So, and when it comes to the acetazolamide, it was the first introduced carbonic anhydrase inhibitors. Okay, acetazolamide is the first carbonic anhydrase inhibitor as a diuretic has been used. Okay, and first one is about it is orally effective diuretic with the duration of action with the around 8 to 12 hours of the duration of action. Okay, it's orally effective diuretic, duration of action is 8 to 12 hours. Okay, basically it reduces the rate of aqueous humor formation and used to be reduce the intraocular pressure in the glaucoma, right? So like glaucoma is a eye related things where some kind of moisture or extent of water will be there actually. So to remove that extent of water also will be used this acetazolamide. Okay. Next, another diuretic has been given as a carbonic anhydrase inhibitor is about the methazolamide. Okay, so methazolamide is almost similar to the acetazolamide. That means there is a heterocyclic ring and followed by the sulfonamide and N-acetyl group, right? Apart from that, there is one extra methyl group here, extra methyl group. Okay, this is a CH3 group, right? So because of this methyl group, this is called as a methyl acetazolamide. We can call it as a combined these to call it as a methazolamide as a commercial name. Okay, so methazolamide is a commercial name. So here when it comes to the IUPAC name of this methazolamide is about the again, right, N5 aminosulfonyl and 3 methyl. Okay, this is where the 3 methyl, the nitrogen number, and followed by the like 1 and 2 1 and 2 and 3, right? 3 methyl 1,3 thiazole, okay, 2,3H ylidine and acetamide. Okay, it is called as this methazolamide IUPAC name. Okay, so when we compare with the in terms of activity with the acetazolamide and methazolamide, right? So it has a better penetration into the eye compared with the acetazolamide. Okay, so we have used that condition called glaucoma, right? Glaucoma we can use it for both acetazolamide and methazolamide. Instead of acetazolamide, they can extensively use the methazolamide because it has a better penetration, okay, in the eye when compared with the acetazolamide. Okay, so when it comes to the when you compare the SCR structure act relationships, okay, what are the key important things to be remember is the in this class of diuretics is about the acetazolamide and methazolamide are the simple heterocyclic sulfonamides. These are the heterocyclic sulfonamide. Okay, the heterocyclic ring present here is about the thiazole ring, right? And followed by the sulfonamyl group is essential for the carbonic anhydrase activity. Okay, that means carbonic anhydrase inhibitory activity. The sulfonamide is very, very important. Okay, this must be important moiety which is usually involved in the inhibition of this carbonic anhydrase inhibition, and this sulfonamide also must be not substituted with this free amine will not be substituted. Okay, if you substitute free amine, the activity will be reduced. Okay, the sulfonyl nitrogen should not be substituted for the activity, right? So that's how we need to be we have to be keep these molecules. Okay, Next is about the dichlorofenaramide. Okay. Next is about the dichlorofenaramide. It is also same sulfonamide derivative. The sulfonamide group is very important for the activity. We know that for the carbonic anhydrase inhibition. Apart from that, the ring which is present here about the aromatic ring, benzene ring with the 2 chlorine substitution. Okay, and 2 sulfonamide substitutions. Okay, that's why it is called the dichlorofenaramide. It's called the dichlorofenaramide. Okay, dichlorofenaramide. Okay. It is also called the dichlorofenaramide commercially, right? So when it comes to this, exact IUPAC name, it's a 4,5 dichloro and meta-benzene disulfonamide, right? Meta-benzene disulfonamide. So people also simply represent like this. Okay, right? It is also a one more structure of this dichlorofenaramide. Okay. So dichlorofenaramide is employed to lower the intraocular pressure by reducing the rate of secretion of aqueous humor. Okay, so it is also one of the best useful diuretic for this glaucoma situation, right? And it is recommended for the treatment of both primary and secondary glaucoma. So it is also highly recommended for the both primary and secondary glaucoma. Okay, so likewise, so in this class we have extensively learned about the carbonic anhydrase inhibitors, their structures and their exact mechanism of action, and each and every drug class of molecule, their uses, and some of the important SAR points which are related to these carbonic anhydrase inhibitors. Yeah, so after learning this molecules, so there is one more thing has been given about the synthesis of acetazolamide. Okay, that means acetazolamide is a diuretic with the star mark. If you look at the syllabus, okay, star mark indicate that we need to be learn extensively about the synthesis of acetazolamide. Okay, so acetazolamide can be synthesized by taking simply the hydrogen hydride, that is about the like NH2 and hydrate water molecule, and followed by the ammonium thiocyanide NH4SCN. Okay, ammonium thiocyanide as a reactant. Okay, so when you react this hydrogen iodide and followed by the ammonium thiocyanide, what will happen? It will give the like 1,2 this thiocarbonyl hydrazine. Okay, thiocarbonyl hydrazine. It's it's a kind of molecule, combined molecule of this hydrogen hydride and followed by this ammonium thiocyanide. Okay, so this is where this kind of molecule will be formed here. Okay, so when you have been reacted this thiocarbonyl hydrazine with the phosgene. Okay, right. So phosgene, okay, it's an inorganic gaseous molecule. So when you react with this phosgene with this thiocarbonyl hydrazine, it will undergo the cyclization. And it will give the 5 amino and 2 mercapto 1,3 thiazole. Okay, right? Thiazole. Okay, it's a heterocyclic ring. The main heterocyclic ring, which is the thiazole ring, having the sulfur and 2 nitrogen adjacent each other, will be formed, which is having the both nitrogen at the 5th position and followed by the thiol at the 2nd position. Okay, right. So now what is the like in the structure about the N-acetyl group and followed by the SH become a sulfonamide. Okay, for that what we need to do, again we need to go for the acetylation. If you do the acetylation for this thiazole derivative formed here in the previous step, what will happen? It will undergo this NH group will undergo the acetylation. It will give the N-acetyl derivative of this thiazole derivative. Okay, having the SH free group at the 2nd position. Okay, and after N-acetyl formation, simply you can convert this thioalcohol group simply by oxidation with the like chlorine gas. Okay, in the presence of water. Okay, undergo this SH group is converted into the sulfonyl chloride. Okay, right. It is the thiazole having the N-acetyl group and followed by the sulfonyl chloride at the 2nd position. Okay, and the sulfonyl group now react with simply the ammonia. Okay, it will undergo the imidation and the sulfonyl chloride is now converted to the sulfonamide. Okay, converted to the sulfonamide. So N-acetyl at the like 5th position and followed by the sulfonamide at the like 3rd position, like 2nd position with the acetazolamide ring. Okay, that leads to gives the acetazolamide as a final product as a synthesis, right? So yeah, like in overall, like the acetazolamide can be synthesized by taking the reactants of hydrogen hydride and ammonium thiocyanate. They'll combine to form thiocarbonyl hydrogen, which is on reaction with phosgene gas. Okay, it will undergo cyclization. That will give this thiazolidine ring having the substitution at the amine group, right, at the 5th position, and SH group, the alkyl group, at the second position. Okay, so one which is on reaction acetylation with the simple acetic anhydride used to form the N-acetyl derivative, and followed by the reaction of this SH thioalkyl group or mercaptan group with the chlorine gas in the presence of water will give the sulfonamide. The sulfonamide derivative of this thiazole ring having the N-acetyl group at the 5th position will react with the ammonia, that will form that will convert the sulfonyl chloride to the sulfonamide. Okay, and that is about the main molecule is called as a acetazolamide. What we call, that is the final molecule we obtained simply by synthesis. Okay.